Okay, so when we're simplifying this, we have three bases, numerical, x, and y. So when we look at our numerical base, what perfect square factor can you remove? 9 times 2, the square root of 9 comes out as a 3, and the other factor 2 stays inside the radical. Okay, move to the base x. How many groups of 2 can we remove from the x's? 2, leaving 1x. And then finally, how many groups of 2 can we remove from the y's? 4, leaving 1y inside. Okay, when we look at this, our original index was an even number. The fact that that's the case means we do have to test for negatives. Bless you. So when we test for negatives in the original form, can x be a negative number? A negative to an odd power is a negative, so the only way that can happen is if y is also negative, which is a possibility. And so these are dependent on each other. They're either both positive or both negative. So when we go in and simplify, or when we go in and check our simplified form, those are dependent. Both are negatives in the version that we're going to check. So when I take a negative times a negative, becomes a positive. So the inside's fine. I don't need any absolute values there. A negative squared is positive, and a negative to the fourth is positive. So do I need to include absolute values anywhere in this expression? No. The signs are going to take care of themselves in that first expression. Okay. All right. I want you to try this next example. See if you can work through that on your own, please. All right. So let's take a look at this second example here. Okay, let's start with the numbers. So 54, what perfect square factor can you remove? Again, this is 9 times 6, so the square root of 9 comes out as a 3, and inside our radical we leave the 6. Take our x's. How many groups of 2 can we remove from our powers of x? 2, so that comes as x squared, and how many x's are left inside? None. How many groups of 2 can we remove from our y to the 6th? 3, with how many y's left inside? None. So here's my expression. What I want to do next is test to see, do I need any absolute values? So when I look at my original form, can x be a negative number? To an even power, yes, it's completely independent of y. So when I test it, I need to test it independent of y. So here, a negative squared becomes a positive. So do I need to put any absolute values around the x? No. So then I move to my y. Can y be a negative in the original form? A negative to an even power, yes, that works. So when I test y, it's independent of x. So if I test the y here, can this y be a negative? A negative to an odd power is a negative. So we don't want it to ever be a negative. So what do I need around that y to make sure this is not a negative? Yeah, so if I put absolute values around my y, it can go either before or after the power. But now that guarantees that this is a negative, and that's will never be a negative. And so I need absolute values around the y there. All right. I want you to try this next one, bottom left. All right. The next one, when you're looking at 1/12, probably the perfect square factor that you can see the easiest is going to be 4. 4, and then 4 goes into 11 twice, with 3 remaining, goes into 32 8 times. So you have 4 times 28. Well, 28 also has a perfect square factor of 4. Right? So really this is 16 times, and this is 4 times 7. So 16 times 7 are the factors for 1/12. So the square root of 16 comes out as a 4, and the 7 is going to stay inside the radical. Okay, when I look at my variables, my base x, how many groups of 2 can I remove from my x? 1, leaving no x's inside. And how many groups of 2 can I remove from my y's? 3. So here is my simplified form. Because my index was a square root or an even number 2, I need to consider the possibility that I might need absolute values. So if I go back in and look at my x's, could x be a negative number? A negative squared is a positive, so x is fine. It's completely independent of y. So when I test it here, I need absolute value, or I need to guarantee that my number is never negative, and the only way to guarantee that in this form is absolute values around the x. Okay, so now I'm going to go and test my y's. Can y be a negative in the original form? Yes, and so when I test it, completely independent again. The only way I can guarantee that this simplified form is never negative is to put what around the y's? Also an absolute value. So when you look at that, what you wind up having is absolute value around the entire quantity xy cubed. Okay? And so that would be your simplified form. All right, so when you're simplifying this, 175 is 25 times 7. So the square root of 25 comes out as a 5. The 7 stays inside the radical. Base x, how many groups of 2 can you remove? 1, with 1x left inside. And with our y's, how many groups of 2 can you remove from the y's? 4 groups of 2 is 8, leaving 1y inside. So this would be our simplified form. And then from here, we're going to look and test, can x be a negative? A negative cubed can only exist if there's another negative to cancel it. Y is also odd power, so these are dependent on each other. If one's negative, then they're both negative. So when we test it, we have to test that dependent nature. Okay, so if on the inside of our radical, a negative and a negative are going to cancel, so we're fine with that. Here, a negative to the 4th is going to become a positive. So the only term that the only factor we need to worry about is the x. And to guarantee that that's never a negative, we would put absolute values around that x. Okay, and so this would be the simplified form. Again, absolute value only around the x.